Welcome to lesson 3 of 4 in this tutorial, covering the topic current, potential difference and resistance. This is the third video in our series of 4 lessons on the topic of current, voltage and resistance. Here are the key learning objectives for this lesson. We will start off by looking at potential difference, move on to voltmeters and ammeters, cover resistance, and finish off with some calculations. Here are the AQA specification points for this tutorial. Feel free to pause the video now and have a quick read through them before we begin. We'll start off by looking at 2 important terms. These terms are cells or batteries and components. Cells or batteries are required to move charge around a circuit. They are like electron pumps. In a circuit, you can have cells or batteries and components. The energy given to the charges as they pass is measured in volts. Components will take energy away from a charge as it passes past a component. For example, a buzzer can use the energy to produce sound. We can define voltage as the energy transferred per coulomb of charge that passes. It is measured between 2 points in a circuit. For cells or batteries, the voltage tells us the amount of energy given to the charges in the circuit. For components, the voltage will tell us the amount of energy taken away from the charges in the circuit. Voltage and potential difference are the same thing, and these terms are used interchangeably. AQA exams will set questions such as calculate the PD. In other words, this question is simply asking us to calculate the voltage. Now, we will look at the factors determining current through a component. 2 instruments are used to measure voltage and current. These are the voltmeter and an ammeter. Remember, a voltage for a component or cell is the energy transferred per coulomb. The voltage is measured using a voltmeter. The voltmeter measures a voltage across 2 points. The voltmeter is always connected in parallel with the component. This is shown here. The voltage of a cell is always split amongst the components. None of it can be left over. At the cell, this charge gets given 6 joules of energy. Therefore, the cell will have a voltage of 6 volts. The voltmeter measures the energy difference from before, which was 0 joules, to after, which was 6 joules, in order to work out the voltage. At the lamp, the charge will lose 4 joules of energy. It goes from 6 to 2 joules. This means that the lamp will have a voltage of 4 volts. The voltmeter has measured the energy difference from before, which was 6 joules, to afterwards, which was 2 joules. At the motor, the charge will lose 2 joules of energy, going from 2 to 0 joules. This means that it has a voltage of 2 volts. The voltmeter has measured the difference from before, which was 2 joules, to after, which was 0 joules. We can use different instruments to measure voltage and current. First, an ammeter. This measures the current flowing through a component. Whereas the voltmeter had to be in parallel, the ammeter must be connected in series. In series circuits, the current is the same everywhere in the circuit, as we will see later on, so it doesn't matter where the ammeter is placed in the circuit. The current is measured in amperes. Here's a summary of the comparison between ammeters and voltmeters. Feel free to take a screenshot or a note of this, as this will be very useful when you come to revise for your exams. Resistance in a circuit will slow down the flow of charge, or the current. For a given voltage, a higher resistance is going to mean a lower current. Resistors can act as actual components in circuits. Wires, lamps, motors, and other components all have some elements of resistance. Resistance is measured in ohms. We can measure resistance of a single component by looking at the current that flows through it in amps and the voltage applied across its ends in volts. The higher the resistance, the lower the current for any given voltage. As the resistance of the component increases, the harder it is for the current to flow through the component. This results in a smaller current flowing through the component. Now let's look at a calculation involving current. If we are given two of the following, current, voltage, and resistance, we can calculate the third. We can measure potential difference using the following equation. Potential difference is equal to the current multiplied by the resistance. Here is the short version of the equation. You can use this in AQA exams as long as you know what the symbols stand for. Here are the units for this equation. They should all be pretty familiar to you. Let's imagine that each charge is a runner. The current is the rate of running of the runners and is a measurement of how many runners pass a certain point in a given time. The voltage is the energy given to the runners as they pass the start line, which can be compared to the cell or battery each time. The resistance is the friction on the surface slowing them down. Let's have a go at this exam question. Pause the video now to have a go at it by yourself. The answer is 2 amps. Let's see how we got there. In this instance, we need to rearrange our equation to find the current. Let's write down the one we know first, which is V is equal to IR. To find the current, we would have to do I is equal to V over R. Now we can simply substitute in our numbers. So we have I is equal to 8 divided by 4, giving us an answer of 2 amps. Finally, we will look at one of the required practicals for this topic. We can investigate the factors affecting resistance of circuits using the following method of varying the length of wire in this circuit. This is the setup for the experiment. In the diagram, we can see a voltmeter, an ammeter, a resistor, and a battery. The voltmeter is attached in parallel, whereas the other components are in series. We need to be able to measure the different lengths of wire, so we should place it on a meter ruler. The wire should stay at a constant temperature throughout the experiment. Using the ruler, we can measure out 10 centimeters of the wire. We will attach crocodile clips on either end of the 10 centimeters, making it part of the circuit. Next, we need to record the current in amps and the potential difference in volts. This is done after we close the switch to complete the circuit. Now that we have the current and potential difference, we can calculate the resistance. We can do this by rearranging V equals IR into R equals V over I. We can record the resistance in ohms. Once we have made recordings for the 10 cm length of wire, we can measure out a new section. The new section should be around 20 centimetres. We can now repeat step 4. Next, we need to repeat steps 3 to 6, but each time we do so, we should increase the length of wire by 10 centimetres. We should record our results in a table like this one. We should make sure to repeat the experiment with at least 6 different lengths of wire. We should record all of our results in the table we showed on the previous slide. Using the results we found, we can split a graph of wire length against resistance. This graph should be on a straight line going through the origin. Here is an example. This is a graph of wire length against resistance. The straight line might not go through 0 due to a systematic error. Here's a summary of all the steps in the experiment. First, we need to construct the circuit and place the length of wire on a meter ruler. Using the ruler, we can measure out 10 centimetres of wire. Now, we can close the switch to complete the circuit and record the current in amps and the potential difference in volts. Next, we can calculate the resistance in ohms by rearranging our equation. Steps 6 and 7 involve us repeating the experiment and changing the length of wire. Finally, we need to make sure that we repeat the experiment at least 6 times in order to plot a graph of our results. Exams tend to ask application questions relating to this experiment. For example, you could be asked to find the potential difference across a length of wire, given the results graph and the current through the wire. We've now covered all the specification points for this lesson. Feel free to pause the video now and re-watch any of the sections you are unsure about. We've now completed Lesson 3.